Okay, we are going to continue our trig unit. Today we're going to talk about inverse trig functions. So here are our learning targets. All right, so what are inverse trig functions and how or why are they used? So let's take a look at this situation. It says an airplane is descending to a runway. At an altitude of 15.2 miles, its horizontal distance to the runway is 60 miles. Find the angle of descent or depression. Okay, another way to say that. Now, this is important that we get this exactly right because we want the plane to land right on the runway. If you're just a little bit off with your angle, they could really miss the runway altogether or come up short. So, first, how do we draw this picture? Well, let's say we've got the plane like right here in the air. Okay, now I'm going to draw the horizontal from there. Now this is important that I'm drawing it here because I know angle of depression or elevation is always from the horizontal. So I would start with that horizontal line first and then figure out, am I up or down from there? So it's down from there, right? So this is an angle of descent, so angle of depression. So I know that I'm going to have, this is going to go down and connect. So my right triangle is going to look like this. I know I'm drawing a right triangle, so you should be able to figure that out. Now, so I always draw that horizontal line first and then figure out where the rest of my triangle goes. Now the reason, I know this horizontal distance is, it says is 60 miles. Now we know really this is on the bottom, but this is like a rectangle, so this is also 60 up here. So just kind of keep that in mind, okay? And this height here is 15.2. Now that's, really it's right here, right? 15.2, but it's also the same over here. So I want it to fit my triangle, so that's why I drew it like this. And the reason I'm pointing this out is because angles of depression is the ones that we're kind of messing up. What we're doing is we're drawing our right triangle. Here's the plane, and we're drawing it like this. And then you're saying your angle of depression is right here. Well, that's not true because that's not the horizontal line. The horizontal line is right here. The angle of depression is right here. So make sure when you're drawing these, you're taking your time and actually drawing it correctly. Angle of depression always, or elevation always should be from the horizontal line. Okay, so what we're trying to find is we need to know, so that this pilot lands safely, we need to know what that angle is really exactly. Okay, so how do we find that? Well, that's what we're going to learn today. So here we go. So if you know sine, cosine, or tangent, they have an inverse, just like multiplication has an inverse division. So its inverse is inverse sine. Not a very fancy name. It's abbreviated with this, it looks like to a power of -1. Same thing here for cosine and same thing here for tangent. It just cancels out sine. But really what they're used for is to find the angle measure, and you'll see why that is. So here, so sine, cosine, and tangent are used to find side lengths, right? So let's say I have this sine theta is equal to, and I'm going to leave a little space, x. Okay, now its inverse cancels that out. So if I want to solve for theta, I got to get rid of this, right? So I would take the inverse sine, and I could do that on both sides. Okay, and I'm going to notice I wrote it in front of this x. Okay, so the inverse sine of both sides. These would cancel, and so then theta is equal to the inverse sine of x, and this would tell me my angle. You're like, well, cool, what's inverse sine? Well, if you come on to your calculator here, open up my calculator. All right, the first thing I want to do is go, and I need to change this to degrees. So I'm going to go press mode and then go over to degrees and press enter. Okay, now sine, you'll notice here in the middle of the screen, right above it is inverse sine. Right above cosine is inverse cosine, and right above tangent is inverse tangent. That's what you're going to use to find angles, is those buttons right there. Okay, So now we know what these are. So if I want to find an angle measure, okay, then I can use this inverse stuff. So if I want to know if I'm given cosine and I want to know what theta is, then I'm going to use inverse cosine of x of the side ratios. And if I know tangent theta equals x, then theta is equal to inverse tangent of x. So those are the ones, these three things are really what I want to focus on. I'm using inverse trig functions. Really, that's a fancy way of saying what right here is really trig functions, sine, cosine, and tangent. These are used to find side lengths of triangles. So these are for sides. Okay, inverse trig functions are used for angles. If I want to know angles of right triangles. Okay, so that's really what you want to keep in mind. So if you're trying to find a side, sine, cosine, or tangent. Okay, if you're trying to find an angle, use those inverse sine, inverse cosine, or inverse tangent. All right, back to our problem that we started with. An airplane is descending to a runway at an altitude of 15.2 miles. Okay, so we said this was 15.2 and this was 60. Now I need to figure out what trig function that I can use here. Here's my right angle. Okay, well, 15.2 is the opposite side and 60 is my adjacent side. So this means this is tangent. So I'm going to say tangent of theta is equal to the opposite side over the adjacent side. Okay, now you don't have to do this every single time, but for this one I'm going to show you how I need to solve for theta. That's an angle, right? Theta is always an angle. So in order to do that, I'm going to take the inverse tangent of both sides. So I'm going to just slide this over a little bit. Okay, these would cancel, and theta then is equal to this. Okay, inverse tangent of 15.2 over 60. So I'm going to type that in my calculator now. So I'm going to go inverse tangent. It's in degrees already. Make sure it's in degrees. 15.2 divided by 60. Okay, now you're going to get an answer. We're going to round it to the nearest tenth. And remember, this is an angle, so you're going to put a degree symbol on it. So this is 14.2. Don't confuse side lengths and angles. Side lengths should not have degrees on them, right? So this is 14.2 degrees. So in order for that pilot to land safely, you would say they have to descend at an angle of 14.2 degrees from the horizontal. So that would be my answer. Okay? So ultimately, you would not have to show all these steps here. You would just have to really write out your first thing and then use your inverse tangent. You'll see here how this works. Okay, so let's take a look at this triangle. They tell us that, one thing I wanted to point out. Remember capital letters? Let's take a look at this triangle a little closer. Capital letters are used for angles. That's important. The side across from the angle often is referenced as little. So this would be capital H, and this is lowercase h. And lowercase letters are used to represent sides. Okay, so that's a key thing to remember when you're seeing this. So when you see lowercase g is 28, that means this is 28. Okay, h is 21. It's lowercase, so this is 21. Here's my right angle. Find capital H, so that's the angle here. I want to know what is this. Okay, so in relation to H, I guess I don't need the theta there. In relation to H, I'm going to say, what sides am I given? Well, I have this is the opposite side, and this is the hypotenuse. So I would say sine. So I would set this up, and I would write sine of theta is equal to opposite 21 over hypotenuse 28. Now I'm going to take the inverse sine of both sides. Now you don't have to write that out, but if I do that, the sine on the left will cancel, and I'll have inverse sine of 21 over 28, and that will tell me what the angle is. That'll tell me, I guess I should write h here, really, instead of theta. And that'll tell me what h is. Okay, so now, oh, my writing kind of sucks on this. All right, so let's type it in. Inverse, second inverse sine of 21 divided by 28. And I get 48.6 if I'm rounding that to the nearest tenth. So h is 48.6 degrees. Now remember, that's an angle, so put the degree symbol on there. Okay, cool, we've got that. Now, how do we apply this to some other things? Now, here, there's two problems here. It says solve each triangle described, given the triangle below, round to the nearest tenth. Okay, when it says solve each triangle, what that means is find everything that's missing, okay? So, I have, this is 40 degrees. Now, this is my right angle, so I don't need to find that, okay? That's given to you. And then K is 26. So what does this mean? It means I need to find angle L, okay? I need to find side little l, and I need to find J. So I need to know, what are these three things equal? Okay, well, I know that this is 90 degrees and this is 40 degrees, so I can use, I don't need any trig. I can just use my skills with knowing that three angles in a triangle add up to 180 degrees, right? So 40 plus 90 is 130. If it has to add up to 180, then this means this is 50 degrees. Okay, so cool. I'm going to put this over here. This is 50 degrees. And I didn't really have to do much there to get that. Now, angle L, done. Let's find side L. So we know that this is 50, so I'm going to write this in here. Oops. Okay, side L. So I'm going to stick with using K here. And I know if I'm trying to find a side, I'm going to have to use a trig function, a regular trig function. So to find L, I have the opposite side, and this would be the adjacent side. So this would be tangent from K. So I'm going to move this over here. Okay, so let's see. All right, here we go. I said tangent of 40 degrees is equal to the opposite side, 26, over the adjacent side, which is L. Okay, so here we go. We need to multiply by L on both sides. Okay, these cancel. And L, then I'm going to need to, I'll write this out here. Divide by tangent of 40 degrees. Okay, so L is equal to 26 divided by tangent 40. And we get 30.98, says to round to the nearest tenth, so that actually would end up being 31.0. Okay, so L is 31.0, I'm going to write that in here. Okay, now you would leave your work, but I'm going to get rid of this because I don't have enough room. Now J, this is 31.0 now. Now to find J, you don't have to use a trig function. You can if you want. Even if you want to use a trig function, great. It'll still give you the same answer. Or I know these two sides, I could do Pythagorean theorem to get my hypotenuse. So I think I'm going to try that instead. But again, if you wanted to use a trig function, great. Okay, so here I would say, let's see, a squared, which in this case would be 31.0 squared plus 26 squared gives me J squared. Okay, so then I'm just going to go figure out what that is. (31) squared. I'm just going to do these both. Whoops. Plus 26 squared gives me 1637. So I just added those together right away. So J, then take the square root. I don't know why it keeps zooming in. Okay, gives me 40.5. Okay, so this last side is 40.5. Now notice we only used, we have to find side lengths. So here we use Pythagorean theorem. We could have done trig function. We could have done a different trig function. That would have worked too. But I decided to do Pythagorean theorem. And notice here we used just side lengths. We didn't need to find an angle using an inverse trig function. Okay, so that's sometimes how it works. In this case, it was just side lengths. So again, cool. So now let me erase this stuff. All right, so now they say, well, what about if you're given just a couple of side lengths and you need to solve? So same kind of triangle. I'm just going to use the same triangle here. But now they're saying this side length is 65. This is 55. And you need to find everything that's missing. And again, you're given that J is the 90-degree angle. So in this case, what am I trying to find then? I need to find two angles. So angle K, angle L, and side K. Okay. So I'm going to start by finding angle K. So how do I do this? Well, let's see. I've got, this is the adjacent side and this is the hypotenuse. So that means it's cosine. Cosine of K is equal to 55 over 65. So now if I want to solve for an angle, okay, I'm going to use an inverse trig function. So this means K is equal to inverse cosine of 55 over 65. Okay, let's see what we get. Angle K then, remember this is the angle, so it's going to have degrees on it. So inverse cosine 55 divided by 65, I get 32.2 degrees. All right, so now I know angle K. Now L, I can find by saying, all right, if this is 32.2 degrees, then add it to 90 and then take that away from 180, right? That'll give me angle L. So let's do that. 32.2 plus 90. Okay, we'll go 180 minus 122.2. And we get 57.8 degrees, right? Okay. So that's angle L. All right, now I need to find side K. Now, I think I'm going to stick to find side K. Well, you can use whatever angle you want. I think I'm going to stick with using angle K, and I might use the hypotenuse. So this will be, I'm going to do sine. I'm going to do this and this. Now, you could use a variety. You could use K opposite and adjacent side if you want, but you'd have to use tangent. I'm going to use sine. So I'm going to say sine of 32.2 degrees is equal to opposite over hypotenuse. So then if I just multiply by 65, I get my answer. I'm going to just type that in. 65 times sine of 32.2. And we get 34.6. Now be careful, this is not an angle, this is a side. So don't put a degree symbol on this. Make sure you know which one you're doing here. So that side is 34.6 units long. Okay, so this would be 34.6. All right, and now you've solved that triangle. So again, you should have three things that you're really trying to find in every triangle. And that's how you solve a triangle, find everything that's missing, okay? You have an assignment where you have to do this, write it into your planner, and then check it off once you're done. Good luck.